Hello and welcome back to the Inside.Java Podcast, a podcast about everything Java brought to you by the team at Oracle that builds Java. My name is Nicolai Parlog and I recorded this conversation with Dan Heidinga at JavaOne 2025 as part of a live stream to our YouTube channel. Dan is the JVM Runtime Architect at Oracle and, among other things, member of OpenJDK projects Leyden and Valhalla. In our conversation, we talked about Leyden's goal to improve the startup and warm-up time of Java applications, about ahead-of-time class loading and linking that ships with JDK 24, as well as some features that are available in Leyden's early access build, plus some that aren't. Enjoy the episode. Let's first talk maybe about what Leyden is about, and then we'll get into what Leyden has already shipped in 24, and then maybe we can later see a little bit of an out view from there. So yeah, let's talk about Leyden a little bit.
So if you were watching the keynote, you saw Mark talk a bit about this already. Leyden is focused on making Java start up and warm up faster. Mm-hmm. Java has amazing peak performance, right? We run our applications. We're used to tuning our peak performance, right? We want to get, be able to respond to requests as quickly as we can, take as little time and resources to do it. And Java does a great job of that. And it does that by observing what the application is doing, observing the data, figuring out what methods are called, figuring out what classes are used, the way data flows through the system to find the right paths to optimize and to spend the resources on compiling those. Mm-hmm. So we observe, then we compile speculatively based on the assumption that those observations are going to continue to hold. So the path that we took last time is likely to be the path we're going to take again. The classes we saw earlier are going to be the same classes. Yeah. So we observe, we speculate, and then we use that to get the best performance we can. So we speculated, we compiled new code based on that. We've done whatever other optimizations we can. But we always have a fallback path. Mm-hmm. If that speculation doesn't match anymore, we fall back to something else.
That's like, for example, there's a de-optimization and something like that comes
exactly,
in, right?
Yes. So Java's really good at this model of observe, speculate with fall, and then get good performance based with fallback. And Leyden says we want to make startup and warm up faster. And startup and warm up tend to be slower in an application because of Java's dynamic nature. Mm-hmm.
So before we get there, can you quickly explain, just for those who don't know exactly what startup and warm up exactly means? So we get because to many people I think this sounds synonymous, but you're using it in a very specific way where it isn't actually.
Yeah, and the definitions are fairly fuzzy. So, I'll pick a definition and other people may have slightly different ones. But we tend to think of startup as the time it takes to do the first useful piece of work. Mm-hmm. So you type Java dash, your application or whatever your command is, and your application starts to execute. Yeah. But before you execute your first request, there's a whole lot of things that happen in the system. Yeah. Classes get loaded, the runtime gets initialized, the JIT compilers start up. There's a whole bunch of things that are happening. And that startup is sort of the time to get to that first useful piece of work. Yeah. And then warm up is from that first useful piece of work all the way through till we hit peak performance. Yeah. And you use useful unit of work because I recently made that mistake and Mark corrected me. I thought it was like this the first line in my main method basically. But that's not true because my main method, if it's hello world, then yes, because my first useful unit of work is printing hello world. But if it's a hello world Spring Boot app or whatever Helidon app, then the first useful unit of work includes all the startup of that framework, right? Until the first request comes in and we've responded to that. That's sort of your startup time. Right. So it includes potentially a lot of dependencies that have been pulled in. Yeah. Okay. And there's work done by the JVM during that time, but there's also work done by your application. Your application is, reading configuration files. It's creating loggers and probably more loggers as well. Yeah. And so it's doing all kinds of class path scanning and all kinds of work to set itself up as well. Yeah. So startup is not just a VM thing; it's a whole application thing until that first useful response. Okay. And then warm up is from there until we hit peak performance. So it's a bit of a fuzzy range. You can shift things because things that happen in startup will continue to happen in warm up. You might load new classes as you take different paths. You might continue to compile things. You might continue to profile things. So it's not a clear separation. Yeah. Yeah, and it said like peak performance itself there's not like one point when the JVM says, I reached peak, I'm done now. Yes. Yeah. Okay, good. So we covered that. So startup and warm-up time. And you said you were going to tell us how Leyden is trying to make those shorter by leaning on Java's dynamic and speculative nature. Yes. So Java does a great job optimizing speculatively, right? So it observes, it speculates the observation is going to continue to hold, and then it does the optimizations with the fallback. We said, what if we didn't just speculate during an application? What if we were able to speculate across applications? So, and not across two different applications, but across different runs of your application. So you run your application once in a training mode, and then we can use that to record observations that we can use to speculate and then optimize your production runs. So when I say training run, people often say, what do you mean by that?
Yeah.
The best training run is to run your application. Right? Like, obviously, your application is going to do the same things it does.
Yeah.
So, if you can train in production and then use that, that's sort of the best thing you can get.
Yeah.
Otherwise,
sorry to interrupt you, but those, for example, people who do like something like canary deployments, actually in kind of a good situation, right? If they already set up the application in a way where they take the current version and launch it for like a small amount of users, then that would be the perfect training run, basically, right? If then the full rollout would then include this information.
Yes.
Okay. Yeah. So that's basically the optimal case. Yeah.
Yes.
Yeah.
So, but otherwise, you can take an integration test that execute some common paths through your application and use that as a training run. And you can run that during your build pipeline as well. So you can pre-train or do it at deployment. It really depends on what works best for you.
Yeah.
But the closer the training matches what your application does, the better you get.
I would expect that performance benchmark suites, if people have those, if they are performance sensitive, then often they do have performance benchmarks for their own application. I would guess that those are probably also decent. I mean, I don't mean like micro benchmarks, like full end-to-end benchmarks.
They're good. The big thing you want to avoid with a training run is loading classes that you don't need in your production run. So if your benchmark loads a whole bunch of classes that will never be used in production, that may not be the best training run.
That also excludes unit tests by definition, right? Because like the entire unit testing frameworks and assertion libraries and all of that is in there.
It does. There are probably ways you can configure things to make that more useful.
Yeah.
Because what we've done so far and what we've shipped in JDK 24 optimizes the 3 built-in class loaders. So the system loader, the application loader, and the extension loader.
Okay. Yeah, right. Let's talk about that though. So what is already or before we get there, maybe because we talked about training run, but I know that there's 3 steps, right? Like the training run is the first, that's gathering the data. Let's briefly cover the other 2 steps maybe that's going on.
So the second step, we call it the assembly phase. So in your training run, you record an AOT configuration. And that's where the JVM records the observations it's made of your application. So it records things like which classes you loaded. It records things like which classes were linked together, which constant pool entries were resolved, which Lambda expressions had actually been turned into real objects that we used. And we record that information so that in the assembly phase, where we don't run your application, but we do start a JVM, we can use that to sort of take these classes, to load them, and then to pre-link them together. And out of this, we generate an AOT cache.
Okay.
And then at deployment,
you
use that AOT cache and you run your application.
Yeah.
So your application runs in training and it runs in deployment, but it doesn't run in the assembly phase. The assembly phase is just a special JVM time for us to sort of put things together in the right.
Okay, just out of curiosity, so I can see that the length of the training run is however long that takes, and then the production run is the time the production run takes. But the assembly phase, do you have is it a matter of seconds even for a large application, or would this take longer? Do you have just a ballpark? I know that this is wildly different depending on application, but just generally speaking, what's the time unit that you measure this in?
So now I'm blanking on data.
No worries, it's all good.
It's in the seconds range. It's something that we want to be faster.
Oh, okay.
We've recently had contributions from other groups who've been working with us that have looked at how long the assembly phase takes. Right now, what we're doing in the assembly phase in the Leyden early access builds is more than what we're able to do in JDK 24. So we're doing some code compilation there, and that was a single-threaded process. We were compiling a whole bunch of methods on one thread, and so that was taking longer than we needed it to. And so in the Leyden EA builds, we've recently changed that so that it's a multi-threaded process. We're compiling across multiple threads, and that has significantly sped things up.
Okay, but I'm hearing that again, there's not a promise, and it's not, and it might definitely, it depends widely, I would assume, on the number of stuff that you're actually doing, which means how large is the application, but also how many of these optimization steps are you taking. But I'm hearing you're measuring this more in seconds than in minutes, for example, just to get a gut feeling for this. Okay, good. So now we have the 3 phases, and we already know that you plan, or that you do some things in 24, and you mentioned that we do more things in this EA build. So let's focus on 24 for now. So what happens, and that's experimental? No, it's final, right?
It's final, yes.
It's already a final feature. Okay, so people can already use that. So what do you do in 24 on this cache?
So in Java 24, we have JEP 483, which is preloading and pre-linking classes. So in your training run, we recorded which classes you loaded. And we want to load them in the assembly phase. And we want to not only load them, but we want to link them together. So if you're familiar with CDS, CDS loads classes as you request it. So your application might be talking about a new class it hasn't talked about before, and it says, oh, please go and load this, and CDS has some VM metadata for that class, and it loads it in as you ask for it. But because it happens on a class-by-class basis, those classes are all independent. We can't speculate about the other classes that are going to be loaded before you do the single request. So in 24, with our AOT cache, we are able to speculate that this set of classes is all going to be reloaded as a group. And that means that we can not only load them one at a time with their metadata, but we can actually link them together. So we talk about Java being dynamic. And one of the dynamic features of Java is its symbolic linkage. So when you have a method that has a get static of, or sort of talks about a static field on another class, the bytecode for that is a get static. But that bytecode doesn't link to that field. It links to it by name. It names the class and the field. And so at runtime, the VM runs through that class's metadata, and it finds the actual address or the offset that it's going to use to go and get that field for you. And that is really important if you do things like separate compilation steps, for example. If this were not the case, then it would be really hard for one jar to depend on another jar, because another jar might make internal changes that would reorder fields or whatever. And if that would be burned into the bytecode, like specific position with an object, then this would not work, right? So this dynamism is something that is not just some fancy academic thing, but we're using it every day. Every day you take a new jar from another library, or you run Maven update or whatever you end up running. That's using our dynamic linkage. So at runtime, though, the VM has to turn that into real addresses and real offsets that it can use to actually execute. And what we're able to do with the JEP 483 is we're able to do that linkage ahead of time. So rather than doing that symbolic resolution, on first access, we've done it ahead of time, so you don't have to do it again. You just can execute it as though it's a direct reference there. Now, we can do that for field access and method, itables, vtables. All these things have special indices that help you optimize there, and we can link those as well. But even more importantly, we can pre-link Lambda expressions. So when you have a Lambda expression in your code, that gets turned into an invoke dynamic in the bytecode. And there's a bunch of work that's done to spin a class file to then go and connect that and load that and whatnot at runtime. That's a lot of work, right? The initial Lambda setup is quite some work, And so what we've done is we said we can do that ahead of time. We can do that in our assembly phase for invoke dynamics that we know about. So the string concatenation factory, the Lambda meta factory, and we're looking at other ones as well to see what we can do. We can run those ahead of time, have them pre-linked and preloaded and ready to go. Yeah, nice. And that covers all the things that are in 24 right now, yeah? Yes. Okay, so let's look a little bit down the road. What are other things? Because you mentioned the Leyden EA build, and I think there's more optimizations in there, right? So JDK 24 sort of lays the foundation for our future optimizations. Because we've brought these classes loaded and linked in as a group, and they all have a stable identity then. And what that really does for us is it means that we can use that identity to attach other data to. So in your class, you might have run some method and collected some profiling data for the hottest methods. We can then take that profiling data in the Leyden EA builds and save those profiles and reuse those later as well. Okay. So rather than having to start from loaded classes, and re-execute and rediscover the profiles, we can say, well, we have a profile already from your training run. That profile likely holds again we can use that to drive the compilation that we do afterwards.
But in that scenario, the JIT compilation would still happen in the production run. So it's not. So you're not ahead of time JIT compiling.
We are. We're doing
that
both.
As well. Oh, okay.
Yes. So we do the profile collection, and that gives us more options. Once we have the profiles, we can say, okay, we'll compile in your application just like we do now, but sooner.
Yeah.
Or we can say, well, let's do that compilation ahead of time. So we can do the compilation in the assembly phase as well, and we can start you with the precompiled code.
Yeah. Okay.
So we have options. And in particular, because we have the profiles, if the code that you're running no longer matches, maybe you loaded another class, maybe you there's a path that your training never took that you start taking all the time, we're not stuck with the code that we compiled ahead of time. We still have that fallback. We can say, wait a minute, our speculations don't match anymore. Let's de-optimize, use the profiles we saved, use the new profiles we've collected, and recompile.
Yeah. So when we talk about, in general, not specific to this performance optimizations, Java is always trying to make the correct case first and then look for optimizations or improvements later, but make sure it's correct. That's the most important part, even if that would be slow or whatever. And then here's something similar here where we say, okay, if your speculative data works out, you're getting a lot of performance for free. But if it doesn't turn out to be correct, you're not bound forever in the slow path.
Yeah.
But you can change over to the fast path. You just take longer to get there. Yeah. So in that sense, earlier I said correctness first. You always get correctness. Here you would say you always get good peak performance, but if the profile is right, you get there immediately, and the profile turns out not to be correct, you will still get there. It will just take longer.
Yes.
Okay. Yeah, interesting.
Java's rarely a pick one, lose one. It's a pick both. And so here we're giving you both ahead of time and just in time.
Okay.
And that lets us give you the best possible peak performance.
Yeah.
And get there quicker.
Yeah, that's pretty exciting. Yeah. So let's look at some of those numbers. We need to describe them since the audience can't really see them. But I think what I see here is a bunch of bars, and they all top out at 1,000. So that's probably the default scaled performance, launch time or startup time.
We normalized it.
Yeah,
we wanted to make sure that the point of this is not to compare the frameworks together.
Yeah.
These are the sort of the getting started applications for each of the major frameworks that we've been looking at.
So we have here Helidon, Micronaut, Quarkus, and Spring Boot as those are like Hello World examples, if I get that correctly. And it doesn't matter how long they take exactly, but the yellow bars are that's the regular time it takes.
That's
normalized
a JDK 24 build, sort of out of the box, nothing added to it. That's what you get. Then if you take it and train it with JDK 24, we get the gray bars. So you do a training run, you do an assembly phase, and then you use the AOT cache. We get a 2.5 to almost 3x.
So when this is scaled to 1,000, so we're at like 350, so like 35% of remaining time. That's massive, though. It's like a 70% improvement. That's more than I promised people when I talk about this.
That's a large improvement. Now, these are small applications. These are getting started, and they're loading a lot of classes and doing a lot of resolution. So this is sort of a great case for what we can do.
Yeah.
The last set of bars here is Spring Boot's Pet Clinic, so something a little bit larger.
Yeah, a little bit closer maybe to like a small microservice-ish application, backend application, yeah.
And we see, the gray bar is not as big of an improvement because class loading doesn't dominate as much of that.
So it's like a 40% improvement, which is more in line with what I read from the JAP. Okay, that's where that number comes from, right? Because these are more artificial, the first Hello World ones. This is closer to what you can expect in production.
Yeah. And then what we see, though, is that the green bar there, which is what we get with the Leyden EA, is a larger improvement for the larger application because you're getting into the compiled code sooner.
Right. So the Leyden EA bars for the Hello World ones are at around 250 to 320, which is just a little bit better than what JDK 24 already does.
With the JDK 24, it's the class loading and linking for a Hello World type application, whether it's even with its a microservices framework or something else with it, it's still a lot of class loading and linking and not a lot of JIT compilation.
Yeah.
And so with the EA build, where we get more profiles and more precompiled code, you get a bigger benefit with a larger application.
Yeah. And does the Leyden EA build... So let's talk about a little bit the future. So I guess the goal is to pull features one by one from the Leyden EA build into JDK mainline. Do you have... I guess you do. How many more ideas do you have beyond what's in the Leyden EA build? I'm sure the Leyden EA build is not the end of the line, right? I'm sure you have more ideas and probably more hypothetical or experimental ones that you're not sure whether they pan out. Can you give us an insight what it is?
Even with what we have in the Leyden EA, there's a lot of work to be done to productize. Right?
Yeah.
We have to find the right tuning. There are different kinds of compiled code that we have. Some of that code says, hey, the first time you talk about a class, we have to initialize it. So we have to do something to make sure that code still has that initialization hook in it. But we don't want that long term. So we have two flavors of code that we can put into the AOT cache. Ones that have these class initialization barriers in it, and ones that are sort of your peak optimization. So we're working on sort of the policies for tuning, when do you switch between those pieces of code? How do we optimize that? So there's a lot of work to go on in those pieces. We're also looking at what else we can do. So one of the goals I have is to be able to take other class loaders and be able to apply the same kinds of optimizations to user class loaders.
Right, we kind of skirted past that. You mentioned that we do the 3 basic class loaders that are part of every JDK run or Java application run. But you're right, like applications can bring their own class loaders along, and you're saying they're fully excluded at the moment from these optimizations?
They are.
Okay.
Right now, when you create a class loader, it's dynamically created at runtime. So we don't have the hook to know which class loader it is, and we don't really have that stable identity yet to know that this class loader is always the same class loader.
Right.
So there's work to be done to say, what have we done here? How do we extend it to your class loaders, to other class loaders? So that's on our list as well. And then there's more sort of speculative things. Everybody always thinks, the more code I can run ahead of time, the better. And we're taking a very cautious approach to that. Not because it's a bad idea, but because it's a very complicated idea and it's very easy to change the meaning of your program. Yeah.
That's like the classic, you have like a static field that initializes to current time. If you run this ahead of time, suddenly the application thinks it has been running for like days when it has probably just been seconds. Yeah, there's clearly some things that are hard to know whether you can pull them correctly. So I know this is a very speculative question. But what do you think, how low can you get that green bar at some point? This is not a promise. This is just your personal, hopeful guess for the future. So please, people, don't make me regret asking this. Don't take this to the bank. Just do you have an idea of how close how low you can get? Or a hope? Or you just don't want to say it? That's
I don't want to say, because I mentioned earlier I've been on Valhalla, and I've been predicting Valhalla will ship soon for years. So
same. So in the same boat here. But I also learn now. I learned the hard way why Brian is very cautious with these predictions.
Yes, I've been wrong enough years in a row that I'm not going to make predictions ahead of time.
So this is why we don't do it. We don't do it because we're mean. We do it because we're young and eager, and then we get burned, and then we realize, okay, that's a bad idea. Okay, Dan. Anything else you want to tell me or the audience before we wrap this up?
That we love feedback. Pick up the EA build, pick up JDK 24, start using the command line options. Let us know how it goes.
Yeah, cool. Thank you very much, Dan. And see you around the conference.
All right.